In this video, I will be discussing GATE Chemistry 2020 question number 48. Among the following, B12H12 2 minus, Ni5CO12 2 minus, C2B9H11 2 minus, RH6CO16, OS6CO20, B5H11, B6H10. The total number of species having nido structure is given atomic number of hydrogen, boron, carbon, oxygen, nickel, rhodium and osmium are 1, 5, 6, 8, 28, 45 and 76 respectively. In order to answer this question, we should have an idea about Wade's rule, which is also known as polyhedral skeletal electron pair theory or Wade-Mingo's rule, which helps in predicting the structure of clusters such as boranes and carboranes and can also be extended to other metal clusters too. This rule is based on simple electron count on a cluster, and this table will act as a guideline. We will learn how to find number of skeletal electron pair as we solve this question. Let us start by taking the first cluster given to us, P12H12 2 minus. This follows the formula BnHn 2 minus, and hence from the table we can directly tell that this cluster is having a Closed structure. But I will also show you how to find the number of skeletal electron pairs, and we will cross-check the answer obtained from both the methods. Boron, as we know, the electronic configuration is 1s2, 2s2, 2p1 and it has a total of 3 valence electrons. Similarly, hydrogen has 1 valence electron. Thus, the total electron count on this cluster B12H12 2 minus will be 12 into 3 plus 12 plus 2 from 2 negative charge, giving a total of 50. For formation of one BH bond, 1 electron is provided by boron and 1 by hydrogen. So, total 2 electrons are utilized for one BH bond formation. Here, there are 12 BH bond and hence 12 into 2, 24 electrons are used for BH bond formation, and the remaining number of electrons, that is 50 minus 24, will be used for the cluster formation. And when we divide this value, that is 26 divided by 2, we will get the total number of skeletal electron pair, which is 13 in this case. Hence, it have n plus 1 number of electron pair, which also falls in Closed structure. The answer thus can be derived from both the methods. But if we know the formula, we can directly derive the answer for such questions and it will save the time. The next cluster given to us is Ni5CO12 2 minus. For such metal clusters, in order to find skeletal electron pair, the formula is total electron count minus 12n, where n is the number of metal atom, divided by 2. First, let us calculate total electron count. Nickel has 10 valence electrons, and since 5 nickel atoms are present, we will multiply 10 by 5 plus 2 into 12, 2 from each carbonyl and 12 carbonyl are present, plus 2 from the 2 negative charges, which will give a total of 76. Total electron count minus 12n will be 76 minus 12 into 5, that will be 16, divided by 2 will give the number of skeletal electron pair. This follows n plus 3 and falls under Arachno. The next one is C2B9H11 2 minus. This is called as a carborane. Here we need to know the concept isolobal analogy, which is simple but important. We know carbon has 4 valence electrons. Similarly, one boron has 3 and one hydrogen has 1 valence electron, totally giving 4 electrons for 1 BH fragments. Such fragments having same number of valence electrons are called as isolobal. Here, carbon is isolobal to BH. Hence, carbon can be replaced by BH in this cluster, and thus we will get BH2 twice B9H11 2 minus, which also can be written as B11H13 2 minus. This is also same as B11H11 H2 2 minus. Now, from B11H11 H2 2 minus, if I remove 2H plus, 2 negative charge will remain, thus giving the formula B11H11 4 minus. By writing like this, we can directly find out the cluster structure using the formula given in the table, and the cluster is Nido structure. The next one is RH6CO16. Here skeletal electron pair will be total electron count minus 12n divided by 2. Total electron count equal to 9. There are 9 valence electron on each rhodium into 6 rhodium plus 2 electron is provided by each carbonyl. So 2 into 16 giving a total of 86. Total electron count minus 12n will be 14, and the skeletal electron pair will be 14 by 2, that equal to 7. Thus follows n plus 1 and comes under Closed structure. The next one is OS6CO20. This also can be solved as the previous one by finding the skeletal electron pair using the same equation. Here the total electron count will be 8 valence electron in osmium into 6 osmium plus 2 electron provided by each carbonyl into 20, that will give 88. And total electron count minus 12n will be 16, and skeletal electron pair equal to 8. That means 6 plus 2 is giving 8, and it falls under the category n plus 2 Nido structure. The next one, B5H11. This can also be written as B5H5H6. And from here, if I remove 6H plus, 6 negative charge will be present, and we can write this as B5H5 6 minus. This will fall under the category BnHn 6 minus, and hence has an arachno structure. The last one is B6H10, which also can be solved as the previous one, where this can be written as B6H6H4, and from here we will just remove 4H plus, giving 4 negative charge to the cluster, and thus it falls under the Nido structure. So our question was, among the following, the total number of species having Nido structure, and the answer is 3, which are C2, B9, H11, 2 minus, OS6, CO20, B6, H10. For further details, please visit classes of Professor M.S. Balakrishna in NPTEL, and the YouTube link is given below.